Hey teams, Mr. Munro here to talk to you about AO6 for a linear equation converting between tables, equations, and graphs. This is actually the second tutorial in a three-part tutorial looking at this. Uh, the first tutorial was on converting between an equation to a table and then a table to a graph. So if you're still a little shaky on that, or if you haven't watched that yet, I strongly suggest you do that first. In this second video, we're focusing on converting between a table to an equation. So that's what we're going to look at today. So we've got a little table here, and the table follows this visual relationship here. So for the first pattern, you're starting with 4, then 7, then 10. Before we start looking at that pattern and looking at that table, I just want to recap exactly what a linear equation looks like uh, for algebra. So what the basis formula is for that linear equation. So the basis formula for that linear equation is y equals mx plus c. Now y is that y value, it's that unknown y value. X is the unknown x value. M is the amount that the equation is increasing or decreasing. It's the sort of the a good way to describe it is the gradient, or the amount it is moving up or down as you move from left to right. And C is sometimes referred to as a constant, but during this video I'm going to refer to it as pattern 0. And you'll understand why in a little moment. So that's our basic formula, y equals mx plus c. So let's have a look at our table here. Let's fill this thing in. So I said the first pattern starts with 4, moves on to 7, then 10. I want to identify and see how much is being added each time. And you can see there's 3 being added on each time. So as we move down the table, as x goes up by 1, y goes up by 3, which means this one here is going to be 13, this is going to be 16, this is going to be 19, this is going to be 22. Now this is really important for us to know because this increase tells us what the m value is going to be. Right? In this case here, the m value is going to be 3 because as the x value goes up by 1, the m value goes up by 3. So that's the first part of our equation that we're going to fill in. Right? We find the m value by seeing how much the y value increases when the x value increases by 1. So as the x goes up by 1, the y goes up by 3. So that gives us our m value. Now the next part we're going to look at is how to identify that c value. And this is why I always refer to it as pattern 0. Where students will often get themselves stuck is they will think that pattern 0 is going to be 4 because pattern 1 is y, or pattern 1 or pattern where x is 1, y is 4. In fact, what you're looking for is the y value for pattern 0, or when x equals 0, what does y equal? Let's put it this way. We said here that as x was increasing by 1, or as we were moving down the table, this was increasing by 3. You could say the opposite as well with as much accuracy. You could say as you move up the table, it's decreasing by 3, which means if we moved 1 up from x is 1, y is 4, then x is 0, y is going to equal 1. This is the value that we're looking for. We're looking for that metaphorical, that idea of when x is 0, what's 1 going to equal? If we're doing it here, it would be, what does pattern 1 look like? Well, sorry, what does pattern 0 look like? Well, pattern 0 is just simply going to be one box. So our C, our pattern 0, is 1. So this is our formula here. Remember, the 3x comes from the fact that it's going up by 3 as you move down. So going up by 3 as you move down. And the 1 comes from that metaphor from that pattern 0, that when x is 0, y equals 1. Let's try an example. Let's try an example together, and then I'll get you to try one on your own. Let's have a go at this one here first. So in this case, what is it increasing by each and every single time? Remember, this is what gives us our m value. So what are we increasing by each time? This is increasing by 4. That's increasing by 4 as well. That's increasing by 4 as well. Fantastic. So in this case, our m value is going to be 4. That's the amount we're increasing by each time. Okay. Now, what's our x equals 0 value? What's our when x equals 0? What's y going to be? So we need to go. We're going down by 4 here. So we need to go up by 4. We need to go down by 4 here. So remove that, reduce it by 4. That's going to be 1. So our constant is going to be 1. Now, it's worthwhile at this point just actually like checking a couple of these points, because if you're not sure whether you're getting this right to begin with, if you're a little uncertain, it's actually worthwhile substituting in a couple of these values to begin with. So let's try that. Let's substitute 3 and 13. Now, if we get this correct, we should be, so 4 times 3 plus 1 should equal 13. If I've gotten this correct, it was a good way to start anyway. If I've gotten this one correct, that should make sense. That equation should make sense. So 4 times 3 is 12. 12 plus 1 does equal 13. So that's a good start. Let's try another one. Let's try 4 and 17. So let's try the same thing. That should equal 17. 4 times 4 plus 1 should equal 17. Well, that's 16. That's 16 plus 1 equals 17. So fantastic. That's right too. So it looks like this equation is correct. We can do a little, quick check, a little quick self-check to make sure we're on the right track here. Now, I've thrown you a little left fieldy one here, but you know what? I think you're good enough. I think you're smart enough to be able to get this one. I think you'll be able to figure it out. What I do want you to be really careful with when you attempt this one here yourself is the fact that this is going down, right? We're going down as the x value increases, the y value is decreasing. So be careful about this one. Have a careful think about what you think the formula is going to look like. I'm going to leave you to this one. I want you to see how you go. We'll discuss the answers in a moment. Off you go. All right, how are we doing? We feeling a little bit confuzzled, or do we think we figured this one out? So let's just go through the exact same process we did last time around. We'll see how we go from there. So we're saying as the x was increasing, what's going to happen to the y? So in this case here, it's going down by 2, down by 2, down by 2. Now this is the thing that gives us our m value. So our m value is going to be minus 2. Now this, when we think about this, makes logical sense, because as it goes up, you're taking away more. So as it goes up, you're taking away more each and every single time. So our m value is minus 2. Let's figure out what that c would be. What would 0 be? Now it's going down 2 that way. So as it goes up, it's going to be increasing by 2. So I'm going to increase that one by 2 as well. 27. So that should be 27. So our formula in this case is going to be y equals minus 2x plus 27. We'll just double check that one. Safety first. We'll double check that one. Let's use 3. So that should be 21. 21 minus 2 times 3 plus 27. Well, that's minus 6. Minus 6 plus 27. Yep, that equals 21. So fantastic. Looks like we've got that one correct. So that was the second part of our tutorial on AO6, which is for a linear equation converting between tables, equations, and graphs. Hopefully you were able to understand that one. If you weren't, go back, rewatch the video, maybe rewatch the first video as well. And if you're still finding that a little bit challenging, feel free to discuss it with someone else in your class. Feel free to do some more of your own research. Or, as always, feel free to come and have a talk to me and ask me some questions about it. I might be able to explain it in a different way or in a way that sort of sticks a little bit better for you. So, that was the second part for AO6. Well done, team. See you again next time.